if you follow a few simple rules, is actually pretty easy. So rule number one, so this is, we can call this creating graphs from data. Rule number one. Rule number one. Always have a title. Rule number two. Label the axes, both the x-axis and y-axis. So, for instance, in a graph always has an L shape, not a box like a data table. This is sometimes called the x-axis here. And if we're using our example from last time of the engine size versus the speed, typically, not always, but typically, the manipulated variable is here. So this is manipulated variable. And we usually have tick marks, so create tick marks that count off what you're manipulating. We might start with a 50 cc engine, go to 100, 150, 200, 250, and 300 cc. This is just an example, not from our VW experiment. So this is engine size. And we always want to have rule number 3, which is include the units. Include the units. Now, in our example here, the units that we're using are cubic centimeters. Cubic centimeters. That's the typical way of measuring the size of the engine. Okay? Typical way of measuring the size of the engine. This axis, the y-axis, so this is the x-axis. You don't have to write that in your graphs, but just for note-taking purposes, that's the x-axis and this is the y-axis. This y-axis is usually the responding variable, the RV, responding variable. And in our example, that was what? What was the responding variable? Speed of the car. Good. So we'll put our tick marks, and you're going to use graph paper when you're graphing. So you put the tick marks, and let's say it's 40, 50, 60, 70, and 80 miles per hour. So the units are miles per hour. We always want to make sure we include the units. Okay? So this doesn't really match up. I should have matched it up with the data table, but let's say we had a 50 cc engine and it went 45 miles an hour, so we put a little dot there. Our 100 cc engine, let's say it went 56 miles an hour, so I put a little dot there. And actually, let me do this in a different color so it stands out. 150 cc engine, a little faster. 200, 250, and 300, and so on. So this is a typical line graph. And then after that, you would connect the dots on the graph paper. That's the fun part. What this does is it allows you to see your data visually and make a connection between the manipulated and responding variable. And you can see that as the manipulated variable increases, the responding variable increases. There could be some situations where the manipulated variable increases, but the responding variable decreases. You could have a graph that goes like this. Okay, so as the manipulated variable, as you increase the manipulated variable, you decrease the responding variable. This is called an inverse relationship. Inverse relationship. Or a negative correlation. Some of you in your science fair projects might find out that as you increase one thing, another thing decreases. You might find out that. It depends on your project, though.
Wait, what is that bottom word?
Relationship.
Oh.
Yeah. So as you increase the manipulated variable, you decrease the responding variable. And that's an inverse relationship. Okay? You always are going to use graph paper. You're always going to label the axes with words. And you're always going to include the units. And if you have, there's one more thing. If you have more than one line on the graph, you always want to include an answer key. An answer key. Okay. Okay. Let me take some questions. Hold on just a second.